A stalactite grows at roughly 1 cubic centimeter every 100 years. That means the rock hanging above your head in a cave is not dead. It is moving, slowly, molecularly, crystallizing around anything it touches. And if you stayed still long enough, it would swallow you whole, one atom at a time. Let that land for a second. We think of rock as permanent, frozen, the opposite of life. But calcite, the mineral that builds stalactites, is in a constant chemical negotiation with water, carbon dioxide, and time. It is not a thing that formed. It is a process that is still happening. And that means everything changes when you ask the question, what would the physics actually do to a human body trapped inside one? This is not a thought experiment about fantasy. Every single thing that would happen to you is governed by real, measurable chemistry. And understanding it will permanently break your idea of what rock even is. Here is where it starts. Rainwater falls through the soil above a limestone cave. As it moves through decaying organic matter, it absorbs carbon dioxide and becomes carbonic acid, weak, but relentless. That slightly acidic water dissolves calcium carbonate from the limestone rock above. Now it is a solution carrying dissolved minerals. It seeps through a crack in the cave ceiling, hangs as a droplet, and then something beautiful and brutal happens. The carbon dioxide escapes into the cave air. The chemistry shifts. The water can no longer hold as much calcium carbonate in solution. So it deposits it. One microscopic layer, then another, then another. That is your stalactite. It is not carved. It is precipitated into existence, layer by invisible layer, like frost forming on a window, except in geological slow motion. Now put yourself in there. Say you are somehow suspended just beneath the cave ceiling, motionless, as this process begins. The first thing that would happen is not dramatic. A thin film of mineral-saturated water coats your skin. As the carbon dioxide degasses, calcite begins to nucleate, meaning it needs a surface to grab onto and start crystallizing. Your skin, with its textures and oils and microscopic imperfections, is actually an excellent nucleation site. You would become the scaffold. The stalactite would not grow around you like a mold being poured. It would grow on you, using you as its founding structure. Within years, decades at most, your outermost surface would be sheathed in a calcite crust. It would be translucent, pale white, perhaps half a millimeter thick. And here is the part that makes materials scientists genuinely uncomfortable. The mineral would grow into microscopic pores and follicles. It would not just cover you. It would interlock with you at scales invisible to the naked eye. If this blew your mind, subscribe right now. We cover science that textbooks deliberately skip, the wild implications that professors mention once and then never explain. Now here is the deeper layer that makes this even stranger. Calcite does not grow uniformly. It has a crystalline structure, a trigonal system, if you want the technical term. Its atoms arrange themselves in repeating geometric patterns. And those patterns have preferred directions. The crystals would grow fastest along their C-axis, meaning your encasement would not be a smooth shell. It would be a field of microscopic columns, all oriented by the chemistry of the water dripping over you. You would be wrapped in an invisible architecture. A structure that, under polarized light, would glow in stunning interference colors. And here is where the physics gets genuinely haunting. Calcite is slightly soluble. The same water that deposits it can also dissolve it if the chemistry shifts. Your encasement would be in constant negotiation. Layers building up during dry seasons when carbon dioxide concentrations rise. Layers dissolving slightly during wet seasons when water flow increases and dilutes the mineral concentration. Over centuries, this would create growth rings inside the stalactite, like tree rings, but made of chemistry instead of biology. And those rings would record every climate event that happened above the cave. A drought 500 years ago. A volcanic winter. A particularly wet decade. All of it encoded in the crystal layers surrounding you. You would become an involuntary geological archive. Now consider what this means at the scale of deep time. We have found actual ancient organisms encased in cave minerals, tiny creatures, plant fragments, even ancient human artifacts, preserved inside stalactites like flies in amber, but through an entirely different mechanism. Amber traps by engulfing. Calcite traps by accreting. The distinction matters because calcite-enclosed objects are often still chemically active. The mineral continues to interact with what it surrounds. In some documented cases, organic material inside cave formations has been slowly replaced, molecule by molecule, with mineral, a process called permineralization. Over enough time, you would not just be encased. You would be replaced. Your carbon atoms swapped out for calcium and carbonate. You would become the stalactite. Not metaphorically. Literally. Atom by substituted atom. This is what paleontologists mean when they say a fossil is not the organism. It is a mineral replica that borrowed the organism's shape. And the terrifying elegant thing about stalactites is that they are doing this right now, in caves all over the planet, to whatever happens to be in their path. The implications stretch forward too. Scientists are already studying cave mineral growth to understand how to design new materials that self-assemble in layers, biomimetic materials that copy the stalactite's trick of using chemistry to build precise structures at room temperature. No furnace required. No high-pressure manufacturing. Just water, dissolved minerals, and time. Some researchers believe this mechanism could revolutionize how we grow semiconductors and structural materials. The cave taught us something the factory floor never figured out. What you thought was a rock hanging from a cave ceiling is actually a self-assembling chemical machine that records history, consumes whatever it touches, and is slowly, perfectly, replicating the processes that might one day build our technology. You will never look at a cave the same way again. If you want more science that makes you rethink something you thought you understood completely, subscribe and hit the bell. Next video will do exactly that, and you genuinely will not see the twist coming.